Now we'll practice making deductive arguments. One way to make a deductive argument is to use a model, so we can represent something visually and provide the reasons for why the statement is true. The area model is a way to show multiples of numbers, whether they're multiples of 3, multiples of 2 would be evens. You can even use models to do odd numbers, which is kind of a twist on multiples of 2. So looking here, I have a 1 by 3, a 2 by 3, and a 3 by 3. Using inductive reasoning, make a conjecture of what you think the next figure in the pattern would be. Well, if you said it's a 4 by 3 rectangle, I would agree with you. And the reason is each rectangle has 3 rows, and we notice the number of columns increases by 1. So what could this be used to model? Well, I have 3 squares here, 6 there, 9 there. The next would be 12. These are multiples of 3. So I can actually use rectangles to model multiples quite well. So I'm going to go use those models to show that the sum of 2 multiples of 3 is also a multiple of 3. Why? Well, this is true because when you put 2 rectangles together, so we're going to say rectangles where it has 3 rows, and it doesn't matter how many columns, those are multiples of 3. If I put one rectangle, say with 2 columns and 3 rows, and another rectangle also has 3 rows, doesn't matter how many columns, the new rectangles will still fit, and it will have 3 rows, so it will be a multiple of 3. So another way you can write multiples of 3 is by using algebra. So we can use an expression. We could say n stands for the number of rows. So 3 times n, that's a multiple of 3, which makes sense. If n is an integer, then it would be 3 times 1, or 3 times 2, or 3 times 3, and those are all multiples of 3. Now I'm going to use algebra to argue that the sum of 2 multiples of 3 is also a multiple of 3. Why would that be? Well, 3n is one of the multiples, and then I'm going 3p, doesn't matter what I use. P stands for another integer. Well, if I add those two together, I can actually factor out a 3. Since I can factor out a 3 and n and p are integers, that means this number is 3 times some integer. That makes it a multiple of 3. Oh, and that should be since we can factor out 3. All right, so for further reflection, what is one way to represent multiples using a model? Well, the rectangle model is quite handy there. And what is one way to represent multiples using algebra? You can just go whatever number you're doing a multiple of times n.